Welcome to another video for chemistry. In this video we're going to be discussing oxidation and reduction reactions. And this is part one of this discussion. This is just an introductory discussion on this, and then in the next video we will discuss more examples illustrating this concept. So to begin, if an acid-base reaction, the videos that we discussed, or the topic that we discussed in the previous videos, if these acid-base reactions were characterized by proton transfers, right? So if you remember, you have one compound transferring a hydrogen ion or a proton to another, and those were Bronsted acids and bases. So if an acid-base reaction is a matter of a proton transfer from one compound to another, then an oxidation reaction, oxidation reduction, or a redox reaction, these are considered electron transfer reactions. So now we're going to be discussing the way electrons are transferred, and this is in essence the biggest point of chemistry. Really, it's all about electrons and how electrons behave when you have different elements that are combining. In fact, the only reason why elements combine is because of electrons. All right, so let's dive into this a little bit more. Let's look at this example chemical equation of magnesium solid plus oxygen gas. Now this is a pretty cool chemical reaction, not just on the literal side of it, but also like in the visual side. When you put a flame to magnesium in an oxygen-rich environment, you have a really cool fireball that occurs. And in that fireball, as magnesium and oxygen are interacting with each other and combining with each other, you have a lot of energy that's being released in the form of light and heat. And one of the final products of this reaction is you have a magnesium oxide. And this is a solid. It becomes like a grayish powder that looks kind of like ash, or like after a campfire, you have the gray ash that's left over from the wood burning. So let's take a really close look at this reaction to see what's actually happening. All right, so the oxygen is more electronegative, right? So it's more electron hungry. And because it is more electron hungry, it's going to strip magnesium of 2 valence electrons. And we know that it's going to be 2 valence electrons because if you look at the position of magnesium and oxygen on the periodic table, magnesium is in group 2 and oxygen is in group 6. Okay? And because of this, we know the oxidation numbers. Oxygen has a -2 oxidation number, where magnesium has a +2. And what this basically means is that when these two elements react, magnesium is going to be donating the 2 valence electrons, the 2 electrons on its outermost shell, to the more electronegative oxygen, which will receive 2 electrons. Okay, and these happen to go well in the 1-to-1 ratio. So the more electronegative oxygen will take the 2 electrons from the less electronegative magnesium. This is considered an ionic reaction. Okay, so what we're going to do is we're going to split up this chemical reaction into what's called half reactions. Okay, we're going to first take a look at this equation, or this chemical equation, in terms of magnesium. What exactly is happening to magnesium in this equation? Okay, so the half reaction shows us magnesium, and then some reaction occurs, and then in that reaction magnesium loses electrons. Now you'll notice on the far right here I have 4 electrons, okay, where I said before that magnesium actually only loses 2. Well, if you look at the coefficient here, you have a coefficient of 2, which means however many electrons magnesium is donating, okay, you just multiply that by 2 because there's actually 2 magnesium ions involved, not just 1. So because there's 2 magnesium ions, we actually have a total of 4 electrons that are being donated. Okay? So we're only highlighting what's happening to the electrons in each of these elements, and that's what these half equations are going to do for us. So magnesium is losing the electrons, okay, signified by my +2. So if I'm losing an electron, which is a negatively charged particle, If I'm losing a negative, that means I'm becoming positive. Okay? So because I'm losing two particles that are negative, I am becoming a positive 2 charge. So this is my new charge. If you look at the magnesium on the reactant side, it's a neutral charge. It's not a plus or negative on either side. It's just neutral. But because I now lost electrons, I have now become a positive 2 ion. Okay, and that's due to the electron loss. So if I'm losing electrons, that means I am being oxidized. So magnesium in this case is being oxidized. I'm going to show you or give you a mnemonic that's going to be helpful in understanding when something is being oxidized or when something is being reduced. So to be oxidized, oxidized is always losing an electron. Okay, so OIL, oxidizing is losing, or oil. Okay, so that's the first half of our mnemonic. Now let's get our second half. And to get our second half, we're going to look at the second half equation. Okay, so if you recognize our equation again, magnesium was only one of the elements involved. Now we're going to deal with what's happening to oxygen. Well, oxygen is actually going to be receiving those electrons. So magnesium is donating, magnesium is becoming oxidized. So oxygen, so these electrons have to go somewhere. Oxygen, the electronegative, the more electronegative element, will receive those electrons. And in the process of receiving those electrons, oxygen is gaining, okay? Oxygen is being reduced. Think of it this way. Oxygen is receiving a negative charged particle. So if it's receiving something negative, then it's being reduced. Its charge is going down. It's going down. So it's reducing. So in this case, reducing. I know it's a little counterintuitive, or these two words are kind of opposite, but hopefully when you do more practice of these, it'll begin to make a little bit more sense. But reducing is gaining. Okay, I'm only reducing because I'm gaining something negative, which is the electrons. So oxygen is being reduced. Okay, reducing is gaining, or rig. So here's the second part, oil rig. So oil, meaning oxidizing, is losing. So I am losing electrons, and reducing is gaining. Something has to gain those electrons, so it's reducing is gaining. I am gaining electrons, and in the process of gaining electrons, my charge is being reduced, right? So in this case with magnesium, so I have magnesium here and I have oxygen about to combine, and as they get closer and closer together, oxygen is going to attract those electrons. Okay? And as those electrons get closer and closer, magnesium will now gain a +2 charge, and oxygen will gain a -2 charge. And in the process, actually, as these electrons are now incorporated into the oxygen's orbitals, the orbital for oxygen will actually increase in size. Okay, as its charge increases, its electron density will increase, and the orbital size increases. And I end up with a new compound, which is magnesium oxide. Okay, and that's exactly what my chemical equation was showing me. So going back to our half equations now. So if we have our half equations, what we want to do is we want to combine these equations and gain an overall equation here. Okay, so our overall equation is as such. Okay, so I have the magnesium combining with my oxygen, and then I have the 4 electrons that are playing an important role in this equation. And then I have my magnesium +2, because remember I lost my electrons, and here they are right here. And then I have oxygen -2. So here, by adding my charges to my elements, I am signifying where these electrons are being transferred to. So you'll notice here, I don't really have any charges here, but I do have my electrons showing that there will be a loss of electrons from something, and then something will gain those electrons. While on the product side, I show by my oxidation numbers here, these oxidation numbers tell me where these electrons will go. So +2 tells me that I'm losing electrons, -2 tells me I am gaining electrons. So once I have that idea in place, I can actually eliminate my electrons, and I end up with something that looks more like a chemical equation. Now you'll notice on my product side that I still have my magnesium oxide separated, but in reality the ions on the product side, they will combine to form a new compound, which is magnesium oxide. Okay, so magnesium is oxidized and oxygen is reduced in this equation. Okay, and this is the beginnings of oxidation reduction reactions. And in the next video, part 2 of this, I'm going to give you a couple more examples of this concept playing out. Okay? Good luck in your study.